Okay, so now we are moving along to question number 6. Well, let me see if I can change this. Okay, better. Okay, perfect. So question number 6. So first, this question is going to be very similar to the previous exercise that we had. Question number 5. So we can read, like it's going to ask like kind of like the same things. We're going to deal a lot with the minimum and maximum. We're going to use the standard deviation formulas, the average formulas, and calculating like the like evaluating the ones that have the lowest value, the highest value for the opportunity losses, and the best and worst payoffs. So here's a question. Stargard Systems is considering becoming certified to the ISO 9000 series of quality standards. Becoming certified is expensive, but the company could lose a substantial amount of business of its major customers if its major customers suddenly demand ISO certification and the company does not have it. A lot of clients, like when they are working with companies, when you don't have like a certification, like that's a major thing to decide between the suppliers, right? The competitors. So it's a very good competitive advantage that one should have. On a side note, so yeah, it does cost a lot, but depending on the business and the area that you're at, most business would opt to have the certification. Okay, so some more information that we have here is at a management retreat, the senior executives of the firm developed the following payoff table. Okay, so you're gonna have our payoff table here, right? Indicating the net present value of the profit over the next 5 years. So the net present value is like how much to be worth like over the next 5 years, right? Um, and it's about the profit here, not the cost, but the profits. So here we have here two decisions. So the decisions that are involved here are become certified or stay uncertified. These are two possibilities, right? And you have here the customer response. So if their customers have the standards being required, the ISO, or they don't require ISO certification for their suppliers. So the ones that require are this ones, and the ones that don't require are this ones. So this is what they're gonna be dealing with. And then you have the probability, right? So the probability of the standards being required is 46% according to the evaluations of the executives of the firm, and the standards not being required is 54%. So that's what we are dealing with. Just remove that. So the part number 1, identify the type of decision problem and use Excel formulas and functions to determine the following calculations. So the best and worst payoff, we're just going to deal with the minimum. So we already did this before, right? So it's just going to be this amounts there here. So we can start calculating it. Yes, man. And this one is to become certified. So we're just going to select for both. Minimum quantity of 1, maximum equals max, same thing, equals max, same thing. Okay, so we're also gonna add like those columns that we have here, just like in the previous exercise. It's gonna be easier for us like to graph the amounts instead of like calculations, because we do it here, it's easier to visualize. Perfect. I'm just gonna change the color a little bit so we can move on to the next section. The next section is the opportunity loss. So remember that in the previous exercise, all we did was to select, subtract the minimum. So now it's going to be just a little bit different. So we're going to use the next formula. Standards required here minus become certified, right? That's the opportunity loss. So equals max. So same thing. Minus state uncertified amount means they are not required equals max. Now these two columns of still are not required, and then we subtract become certified from that. Equals max, and then we have the column amounts. We subtract the probability of staying uncertified from that. And there you go. Now we have all our amounts. So just like we did here, we can this one. We can do it on the other side as well. It does work like if you copy the numbers, but just to make sure, like you can select, see if it's grabbing, like maybe you didn't paste in the wrong place. Okay, so now we have this portion complete. We know the best and the worst payoffs. We're gonna grab like the amounts from here. And when it's about like opportunity loss strategy. So these two amounts here, we're gonna grab from here. And the opportunity loss, it's from the opportunity loss section, right? So we're gonna select it from here. Okay. So our idea here, what is the type of decision problem that we have? So our options are minimize objective or maximize objective. So in this case, we want to maximize your profits, right? So it's maximize, and what are the payoffs? Having the ISO standard, quality standards, the number of years, so the net present value of the profits. So these are the payoffs. So the decision using aggressive strategy, conservative strategy, and opportunity loss strategy. So this one is going to be like we select like if it's become like certified or not. So the decision that is conservative is just like in this case, it's not risking their profits, right? Well, not making their investment, not spending more money and not having a possible more deduction of their profits. So it would be in this case to continue certified, and then aggressive would be to become certified. That would be like a different opportunity that they have, and the opportunity loss strategy would also be like the one that they're gonna give up in, right? Would be stay uncertified in order to become certified. So now we gotta evaluate this amount here, the payoff value. We already calculated the best and the worst payoffs here, correct? So we're just gonna select from the table the first and the second one, because the opportunity loss we get from here. Payoff for the aggressive strategy, which is become certified, is going to be the 83,000, because you're maximizing the objective and not minimizing, correct? And then the payoff value, okay, is going to be 2,000, because we're staying uncertified. And then the other section, just the opportunity loss. So we're going to select from the other section that we calculated. So 6,000. So in this case, we have the maximum amounts for both of them, and then the opportunity loss is going to be the minimum amount, right? Um, between the options. Charges, outcomes. It's not letting me click. Okay, smallest and the largest one. Okay, because you can see here, this one is the 83,500, right? That's our largest amount. And then we have the 73, so which is going to be our smallest amount. Okay, so between 6, okay, and here the 6 and the 11,000, for example, is also the largest amount. So now it's pretty simple. You're just gonna calculate the standard deviation of the numbers. We already know how to do that. We're just gonna use our simple formula to calculate. So here the first one is become certified. So it's gonna be this amount here, and the second one stay uncertified. So standard deviation, we're gonna use the S just like we mentioned before, because it's a small sample, not a population. Okay, same thing here. Okay, so in this case, which decision is at a greater risk? So you just have to evaluate like the ones that we have. So one is 15,000, the other is 3,000. So the variation is a lot higher here, and therefore become certified is at a greater risk. And it makes sense because like not getting certified is our most like conservative strategy, right? So in this case here, see average, we're just gonna do like the same thing that we did like here, but now instead of standard deviation, we're gonna calculate the average. It equals average. I can spell. For the first amount equals average for the second one. So the decision using average strategy is going to be the second one. So in this case, we're talking about maximizing the objective, right? So if you want to maximize the objective, so average payoff, this one is higher. So it's going to be state uncertified. Okay, now we have our final section. Just have to remember that it's going to be the sum product formula, right? So we don't have to do it manually. So equals sum product, and then we'll just select both. The first one is certified for the array, and then the second array for the probabilities. Just like we did in the previous questions, sum product. Select the first array and the second row, and select the probabilities. Okay, so now I want to know like the decision using the expected value. So 75 is larger than the salary one to become certified. So therefore, we are also going to select your statement certified. Okay, so this completes our question number 6. Now we can go ahead and move to question number 7. Thank you.